Now in the question 4, Li Ting has two laptops, laptop X and laptop Y. In any one year, the probability of laptop X breaking down is zero point 0.1 and the probability of laptop Y breaking down is 0.35. In any one year, what is the probability that in the part 1 both laptops break down? Now in the part 1, probability of both breakdown are given in the question. So we will apply the multiplication law of probabilities here. So here we have 0 0.1 multiplied by 0 0.35, and after multiplication we will get 0 0.035. So the probability that both break down is equals to 0 0.035. Now for the part 2, that the probability of X break down but Y does not. So the probability of X breakdown is given in the question, and that is 0 0.1, but we have to find out the probability of laptop Y does not break down. So for this we will subtract 0 0.35 from 1. So for this we will subtract 0 0.35 from 1, and here we have the carry subtraction. So 10 take away 5 is 5, and here we have 9. So 9 take away 3 6. So here we have 0 0.65. 0 0.1 multiplied by 0 0.65, and it will be equals to 0 0.065. So the probability that X break down but Y does not is equals to 0 0.065. Now in the part 3 we have to find out the probability that exactly one breaks down. So for this we have two possibilities, that X breakdown and Y does not, plus similarly the Y breakdown and X does not. So for this, probability of X breakdown is given, and that is 0 0.1. And since the probability of Y does not break down, we have find out in the part 2, and that was 0 0.65, plus the probability of Y breakdown is 0 0.35. X does not break down, we can just have to take away the probability 0 0.1 from 1, and it will gives us 0 0.9. Now after multiplication we will get 0 0.065 plus 0 0.315. Now we will add up 0 0.315 and 0 0.065. After adding up we will get 5.5 10 1 7 6 1 7 and 8 and 3. So the answer is 0 0.38. Now the probability that exactly one breaks down is equals to 0 0.38. Now the question 5, in a group of 8 boys, 3 are left-handed and the remaining 5 boys are right-handed. 2 boys are chosen at random from the same group of 8 boys. In the part 1, copy and complete the tree diagram. The first the probability for the first left-handed boy is given, and that is 3 over 8. Now for the right-handed boy, the total number of favorable right-handed boys is 5, and the total number of boys is 8. So the probability for the right-handed boy to be first boy is 5 over 8. Now for the second boy, since we have chosen the it is given in the question that 2 boys are chosen at random from the same group of 8 boys. 2 boys are chosen at random. So here we have 3 over 8 for left-handed and 5 over 8 for right-handed. Now we will have to choose two boys at random from the same group. So from the same group, it means where we have to take away from the same group. Two boys chooses at random. So if we choose, we have already chosen the one boy. So we will take away 1 from the numerator and denominator. So 3 minus 1 and 8 minus 1, it will be equals to 2 over 7, and it will be gives for left-handed. Similarly, 5 minus 1 over 8 minus 1, it will be equals to 4 over 7, and that is for right-handed. So the probability that the second boy chosen is left-handed, the probability is 2 over 7. Now the probability that the second chosen boy is right-handed, and that will be 4 over 7. Now the probability that the first boy is left-handed and the second is right-handed, it will be 5 over 7, and here in the last blank we have 3 over 7. Now in the part 1, by using this tree diagram, find the probability that the first boy chosen is right-handed and the second boy chosen is left-handed. So by using the multiplication law of probabilities, for the first is R, we have 5 over 8 multiplied by it. The second is L, we have 3 over 7. Now we have 5 3s are 15 over 8 7s are 56. So the probability that the first is R and second is L is equals to 15 over 56. Now in the part B, we have to find out the probability that one voice is right-handed and the other is left-handed. So we can write it like in the form of two possibilities. The first is the probability of the first is right-handed and the other one is left-handed, plus one is left-handed and the other one is right-handed. Now the probability for the first is right-handed is 5 over 8 and second is left-handed, and that is 3 over 7, plus first is left-handed, that is 3 over 8, and the second is right-handed is 5 over 7. Now we have 5 3s are 15 over 56, plus 5 3s are again 15 over 56. 15 plus 15 is 30 over 56. Simplification, it will gives us 15 over 28. So the probability that one is R and the other is L is equals to 15 over 28. Now in the part 2 subpart C, we have to find out the probability that both boys chosen are left-handed. So both are left-handed. We have the probabilities 3 over 8 and 2 over 7. So here we will apply the multiplication law of probability. So 3 over 8 multiplied by 2 over 7, and that will be equals to 3 2 is a 6 over 8 7 is a 56. For simplification, it will be equals to 3 over 28. So the probability that both are L is equals to 3 over 28. Now in the question 6, a bag contains 6 green cards and 4 blue cards. After mixing the cards thoroughly, Yasser takes 2 cards at random from the bag, one after another. In the part 1, draw a tree diagram to show the probabilities of the possible outcomes. So first we will write down, for green we will use G, and for blue we will choose B. So the number of, we have total balls, so total cards are 6 plus 4 10. Green cards are equals to 6 and blue cards are equal to 4. Now we will use G for green and B for blue. So here we will draw the tree diagram. For the first 2 branches, we have green and blue for the first draw. Now we will write down the probabilities on the respective branches. So for green balls, we have 6, total number of balls is 10, so it will be equals to 3 over 5. For blue balls, we have 4 over 10, and it will be equals to 2 over 5. Now for second draw, from green we have 2 possibilities and from blue we have 2 possibilities. For second draw, we have green and blue, again green and blue. Now we will write down the respective probabilities on the 4 branches. First we have to read one thing from the statement that Yasser takes 2 cards and random from the bag one after another. So in the case of green, we take away 1 card from green and 1 card from blue, so it will become, total number of card will be 9, as we have already taken or chosen or drawn 1 card in the first draw. Now the total number of cards will be 9. So since we have take 2 cards at random from the bag and one after another, so in the case of green it will become 5 over 9, and in the case of blue it will become 3 over 9, and it will be equals to 1 over 3. Now for blue, it will be 6 over 9, and for green it will be 4 over 9. And after simplification, it will be equals to 2 over 3. On the part 2, Yasser said that the probability that both cards are blue is 4 over 25. Explain what he has done incorrectly. So, the probability that Yasser said that both cards are blue is equals to 4 over 10 multiplied by 4 over 10. It will be equals to 4 for the 16 over 100, and it will be simplified to 4 over 5. He did not take into an account that there are three blue cards are left, and total 9 cards are left when the first card is drawn. In the part 3, calculate the probability that Yasser takes out 2 green cards. So for the probability that 2 green cards, we can write it like probability of G and G, and here we will apply the probability multiplication law of probabilities, and both are green. So for this we have 3 over 5 multiplied by 5 over 9, and it will be equals to 5 3s are 15 over 5 9s are 45, and after simplification it will give us 3 over 9. More simplification, it will give us 1 over 3. So the probability that 2 cards are green is equals to 1 over 3. Now in the part B, we have to find out that the probability of that Yasser takes out 1 card of each color. For this, we have 2 possibilities. The one is first is green and the second is red, plus the probability of the first is blue and the second is green. So for this, we will apply the multiplication law of probabilities. So the probability for the green in the first draw is 3 over 5 multiplied by 4. The blue in the second row is 4 over 9, plus the probability for the blue card in the first row is 2 over 5, and for the green card in the second row is 2 over 3. Now we will multiply. So here we have 4 3s are 12 over 9 5s are 45, plus 2 2s are 4 over 5 3s are 15. We can further simplify 12 over 45, so it will becomes 4 over 15. Now we have 4 over 15 plus 4 over 15, and after adding up we will get 4 plus 4 8 over 15. So the probability that 1 card is of each color is equals to 8 over 15. Now in the subpart C, calculate the probability that Yasser takes out at least 1 blue card. So it can easily find out by subtracting the probability of the both green cards from 1. So the probability for both green cards We have calculated this probability in the part 1 and it was 1 over 3. And here we have 3 minus 1 over 3 and it will become 2 over 3. So the probability that at least one B is equals to 2 over 3. Now the question 7. 10 cards are marked with the letters P, R, O, P, O, R, T, I, O, and N respectively. These cards are placed in a box. 2 cards are drawn at random without replacement. In the part 1, draw a tree diagram to show the probabilities of the possible outcomes. So in the part 1, we have P, R, O, T, I, N, 6 letters. So we will take one letter once and only. So here we have, so for the part 1 we will draw the tree diagram in different parts. For the first letter we have P, R, O, T, I, N. Total letters are equals to 10. There are number of P's 2, number of R's equals to 2, number of O's equals to 3, number of T, I, and N equals to 1. And after adding up, they are equals to 3. So now the probability for the letter P is 2 over 10, and that will be equals to 1 over 5. For the letter R, again it is 1 over 5. For the letter O, it is 3 over 10. For the letter T, it is 1 over 10. For letter I, it is 1 over 10. And for letter N, it is 1 over 10. So for the first letter, we have write down the probabilities of the respective branches. Now for the second letter, since 2 cards are drawn at random without replacement, so for card P, for letter P, for the second letter, after first letter, first card is drawn, so there are 9 cards left, so the probability will become over 9 over 9 over 9 over 9 and over 9. So we will write down the probabilities of the respective branches, and after selecting the second letter, we have the probability for the P is 1 over 9, for the R 2 over 9, for O 3 over 9, For T, 1 over 9 for I, 1 over 9, and 4 9 will be equals to 1 over 3. Now for the letter R. The probability for P is 2 over 9. For R, it will be 1 over 9. For O, it will be 3 over 9, and that will become 1 over 3. For T, it is 1 over 9. For I, it will again 1 over 9, and for N, it is 1 over 9. Now for letters O and T, it has further 6 possibilities. In the case of second letter, so here we have P, R, O, T, I, and then again we have P, R, O, T, I, and then so for O we have 3 over 9, and that is equal to 3 over 10. For T we have 1 over 10. Now the probability for the letter P is, in the second case of second letter, we have 2 over 9. For R, we have 2 over 9. For O, we have 3 over 9, and that will be equals to 1 over 9. For T, it will be 2 over 9. For I, it will be 1 over 9, and for N, it will be 1 over 9. Now for P, we have 2 over 9. For R, we have 2 over 9. For O, we have 1 over 3. For T, we have for I, we have 1 over 9. For N, we have 1 over 9. For T, we have 0. Why we have probability 0 here? Just because 1 over 9 minus 1 over 9 will give us 0. Now for letters I and N, we have probabilities 1 over 10 and 1 over 10. Here we have further 6 possibilities. P, R, O, T, I, N. P, R, O, T, I, N. So for P, we have 2 over 9. For R, we have 2 over 9. For O, we have 1 over 3. For T, we have 1 over 9. For I, we have 0. For N, we have 1 over 9. For P, we have 2 over 9. For R, we have 2 over 9. For O, we have 1 over 3. For T, we have 1 over 9. For I, we have 1 over 9. For N, we have 0. So this is a tree diagram to show the probabilities of the possible outcomes. Now in the part 2, Joyce said that the probability that both cards bear the letter O, so the probability that both the cards bear the letter O is 9 over 100. Explain what she has done incorrectly. So the Joyce said 3 over 10 multiplied by 3 over 10, and that will be equals to 9 over 100. But she does not take into an account that we have to draw just only 2 cards are drawn. Cards are drawn with letter O, and 9 cards are left. After first card has been drawn. Now in the part 3 we have to calculate the probability that the two cards bear the letters P and O in that order. So the probability that the first is P and the second is O. So here we have, for the first is P, the probability is 1 over 5, and the second is O, we have 1 over 3. Now we have applied here the multiplication law of probabilities. So 1 times 1 is 1 and 5 times 3 is 15. So the probability that the first is P and second is O is equals to 1 over 15. Now in the part B, we have to find out the probability that the two cards bear the letters P and O. So here we have two possibilities. The first possibility is the first letter is P and second letter is O, plus the probability of the first letter is O and the second letter is P. Since the first letter is P and the second letter is O, we have 1 over 5 multiplied by 1 over 3 plus probability that the first is O and the second is P, we have 3 over 10 multiplied by 2 over 9. Now we have 1 over 15 plus 3 to the 6 over 90. Simplification, it will be equals to again 1 over 15. So 1 over 15 add 1 over 15 will be equals to 2 over 15. So the probability that two card bears the letter P and O is equals to 2 over 15. We have to find out that the probability that both cards bear the same letter. So here we have the probability that both letters bear the letter P. Both cards bear the letter R and both cards bear the letter O. So here we will apply the multiplication law of probabilities. So 1 over 5 multiplied by 1 over 9 add 1 over 5 multiplied by 1 over 9 plus 3 over 10 multiplied by 2 over 9. Now after multiplications we will get 1 over 45 plus 1 over 45 plus 6 over 90, and it will be simplified to 1 over 15, and after adding we have 1 over 45 plus 1 over 45 plus 1 over 15. Now after taking, now we will take the LCM of 15 and 45. So here we have 5 threes are 15 and 5 nines are 45. Now we have 3 ones are 3 and 3 threes are 9. Now we have again 3, and this is a 3 ones are 3. So 3 threes are 9 and 9 5 are 45. So the LCM will be 45. Now by using the butterfly rule, here we have 45 ones are 45, so 1 plus 1 plus 15 nines are 45, so 9 multiplied by 1 is 9. Now we have 1 add 1 add 9. and 15 threes are 45, so 3 ones are 3 is 3, so here we have 3 1 is 5 over 45, and after simplification it will give us 1 over 9, so it will be equals to 1 over 9. So the probability that both cards bear the same letter is equals to 1 over 9.